My name is Kaiwan. I'm from Sapphire AI. The topic I'm going to give you is measuring physical operations real time. It's going to be short, so don't worry if you have a more important thing later. So first, a quick introduction for Sapphire AI. What we do is we leverage existing cameras on different operation sites, and we help them. We deploy computer vision to understand the physical metrics in there and help enterprise better understand, better measure, and improve their operation to boost their medical economy. And obviously, we are a very heavy real-time data streaming company, and we are a customer of Stream Native, and we love them. That's why I'm here to give you a talk. Today I will mostly focus on the application, how we use it, some architecture. I'll give some examples. Also give you some real industry insights of what may go wrong and why this architecture may work, and then a little bit about our use cases and our customers. There we go. All right. Some background. The problem we're solving. The problem we are solving is for a lot of operation-heavy business, how efficient it is, and also how to improve their operation and how much it has been improved. So this may sound a little bit vague to you if you are like not really in operation industry, but this is actually very common. You see operation everywhere, like even in this meeting room. Like for example, 7-Eleven is a retail, but if you own a lot of 7-Elevens, it's operation heavy. If you have a parking lot, you want to understand whether it's fully utilized or underutilized. If it's underutilized, you want to repurpose one of the field. In a amusement park, it's pretty much like full of operation, right? For every single attraction, you may deploy 50 to 100, maybe up to 300. Staff just to operate the rides when you are there, enjoy your good time. So operations everywhere, but one problem is today, not everywhere this operation has been digitized very well. If you don't have the data, you cannot make critical decisions, especially financial decisions and human resources. That's the problem we're trying to solve and try to focus. So if you know a little bit computer vision, or machine learning, you may learn that from school. You're like, hey, isn't this problem already solved? YOLO has been there for like 10 years. When I first play with it, it's amazing. You can stack bounding boxes easily on a laptop. Like even high school student can do that. Like what's the problem? What's the real problem? So I list a few bullet points here. I think the real problem is how you actually landing bounding boxes, how to map that to the real ROI heavy useful business metrics here. So for example, we want to deploy 10,000 pipelines with 50,000 cameras globally around the world with a different time zone. And each of them, they require like 90 to 95% accuracy, not just the bounding boxes, but the actual business metrics. And you also want to maintain a like 3-9 uptime, and you want to deliver that in a very fast manner. You don't want to drag months. You don't want to drag years to make it happen. So all of that are challenges here. So a few more bullet points here. One is bounding box alone is meaningless. You may see a lot of demos online on LinkedIn or everywhere, see fancy bounding boxes, very accurate, but at the end of the day, your customer does not want the bounding box. What they want is how many people has been dispatched in the last 15 minutes, what is my parking lot utilization rate, what's the queue wait time in average, what's the queue wait time now, and how many people are on the floor like now, this moment, so that they can link that to their pricing, they can link that to their staff planning. So what really matters is not the actual technology, the vision task here. You don't really care, like you count that manually or computer vision. CV, ML, just the tooling to make that happen. And of course, they need that real time. They need that to happen. I mean, not real time, not like under. Let's say you have a 100 millisecond delay. That's okay. But if you have like 10 seconds delay, like 1 minute delay, some of the clients, they may start to complain because they work against the data. They live with the data. So the real time is also very important here. And the third thing is the accuracy. One thing to be aware is that it's not one shot. It's not like a demo. Hey, I can demo a 80% MAP or 90% like F1 score. It's a consistent 90 to 95% accuracy for the BI metrics all the time from the day one, every single day, because they rely on that for making important business decisions, operation decisions. It has to be an ongoing process to make sure it happens. And of course, it's an open world. It's not a closed world, even though compared with autonomous driving, which is a dynamic agent in open world, fixed cameras sometimes arguably a little bit more easier. However, still operation may change. Your light condition may change. It's still an open world, and the operation may change dramatically and may be very different from the day one when you activate the camera and the pipeline. And of course, the last thing is large scale. Again, whenever things get to scale, it's going to be difficult. And you want to activate your pipelines very fast in a few weeks, in a few days, not in months or years, right? So overall, it's still a very challenging problem, not quite solved. And we are here to solve the problem, try to bridge the gap. All right, so now I'm going to talk a little bit about our solution. So 4 main components. Camera, sometimes, I think most of the time, our customer directly have the camera already. We don't have to reinstall that. Also, sometimes they want to install a new camera, so we provide them guidance. And we also provide them a GPU server to process the videos, the streaming on site, so that no sensitive data going outside of this operation unit. And then all the data will be sent out to Stream Native. That's where we save all the machine learning bounding boxes, IDs, so that we can replay that. And eventually all the business metrics will go into our own cloud, and then we surface the data to our clients via API or dashboard. So basically 4 components. And then let me give you one actual example, especially if you're not in this area, to see how it works. It's actually very simple. And this is a very basic example I'm giving. So what you see here on the left is a camera in New York pointing outside of the window of our office. It's a beautiful street, and we have a camera and a server connected with that. So you can see we have bounding boxes, we have IDs. It's pointing to the lane, so you can measure the throughput, how many cars has passed by. Very easy, right? And then we send we're streaming the ML output with a timestamp, with the ID, coordinates to Stream Native with Pulsar, and also we store the data in there. And then we have our own data engine. We'll pull data from Pulsar to process it into different metrics. I think the most common one is the ingress, egress, how many cars pass by. And then we can aggregate that with time window, where we can do some filtering, if it's a truck or if it's a car. This is likely the most basic example I can give you. And I think one question you may have is, this is so simple, like why not just have a Python app directly run the first step? Why do you even stream the data to the Stream Native? Why do you bother doing that, right? You actually can do that. That doesn't hurt. But in real world, there are several common cases you may find it very hard, and I list them here. Sorry, 1 second. There will be a lot more, but I give you like very common ones we see here. So the first one is when the pipeline is running, your client is using that. It's production. Sometimes the operation change. For example, the lane changed, or it's in construction, or your camera got kicked, or your camera got reset somehow, some remote firmware updates. So the line or the polygon you draw was not that's not applicable anymore. You have to fix that. And your client is like, okay, I don't care. You fix that. I don't want to lose any day's data because they rely on every single day's data to make critical decisions. You want to fix it without reprocess all the videos. And if you put everything as a single app, the only way you can fix that is to reprocess all the videos, which is very expensive, as you can imagine, because you are going to consume a lot of GPU power. Plus, video recording storage is also very tricky if you have some experience on that. Like the GStreamer is not easy to work with. I'll say it's good. It's just very tricky. You have to compress that. It's not guaranteed you are going to reproduce the same output. If you reprocess the recordings, your FPS may drop, your format may drop. So there are a lot of difficulties. However, if we do this decouple way, another way to see that is you decouple all the vision tasks from your business processing. Meaning, as long as my on-prem detector, vision detector, or vision processor, it can be a detector, tracking, whatever task you want. It can even be a VLLM. As long as the model is performing good, all your ML results will always be valid. You don't have to repeat that computation. It saves a lot of resources. And then whatever needs to be changed on the business later on is totally decoupled, and that's purely this step 2. You can reprocess that anytime at your wish, right? Another good thing is also decouple the work from the deployment team, the hardware team, the infrastructure team, from the software and data scientist team. It's also more optimized for our operation ourselves. Another common scenario is similar, not line change, but you just found out, oh, shoot, some hyperparameter was wrong or needs to be updated. For example, they used to open at 10 a.m. Now they changed that to like 12 let's say 1 p.m. They just close the store in the morning. Somehow the data you generated in the non-operation hour, just a lot of noises, it confuse the customer. You have to change something, right? That also fall into this bin. A third scenario actually happen very often is the internet you have some internet outage, just have no network, everything go offline. And another one I haven't listed in here is your camera can also be totally pixelized and corrupted. So my point here is that in the real world, especially in production, providing this CV solutions for big enterprise, they really care. What they really care is the data quality, accuracy, consistency, resilience. And with this a little bit more sophisticated architecture, you can handle that very well. You have a very low maintenance cost. You can always revisit any operation changes. It's very flexible. And another more complicated application example, at least here, is the live wait time. We are very proud of this product. So imagine whenever you go to an amusement park, are you wondering like how do they calculate the live wait time? When you are checking on the app, they will give you like, hey, 35 minutes. Have you wondered how you got that number? As one way to do that is if you know all the camera, if you have access to all the camera metrics, you actually can have a throughput. You can have the queue size. Then you can derive that data into a very accurate forecasted wait time. So from the compute perspective, is essentially just like another more complicated topology. Like, for example, you may have two cameras looking at the same entrance, joined together. They may run at different frequency, but that's just part of the topology. You join them to calculate some sub-metrics, and then you join that with another group of cameras metrics, and you process that, and then you derive that into, for example, express queues, wait time, and normal queues, wait time. Sometimes you also need to allow some user inputs. That's where the Stream Native APIs and the Flink API is very useful. It allows us to interact with the pipeline. For example, the write shutdown, we just want to clear the queue. Or the write shutdown, we only want to process another 100 people, right? That's where you have a real-time pipeline interacting with your guests in a very smooth way. Okay, so essentially your data, the data is going to arrive into our own cloud, into our own Sapphire AI platform, and just in summary, if you keep doing this like again and again for like 10,000 pipelines or a large scale, what's really important is that we need to have a very fast way to continue developing new applications, because you can imagine not everyone come to you with the same request. Someone may want to measure the throughput, just the throughput. Someone want to measure the throughput with a little bit different time aggregation, or you want to filter out something. Like, it's just inevitable you have some customization. And it's very important you have a way to have a agile development on that. And then you want to fast deploy. You don't want to just hire a group of machine learning engineers and project managers to customize, to make a customized solution just for this client, and you can never resell this to another one. That's not scalable. That's essentially making your company as a consulting agent. And the next one is you also want to, as I said, have a very fast way to update and maintain your pipeline. And then you want to support the large scale. So we have developing two things internally to make this process easier and more scalable. One thing is we develop a no-code internal platform to allow you to just drag and drop to combine different topology. You can also reuse some templates so that you don't have to interact with the code. So, for example, I can bring my own camera, I can bring my own machine, I can just drag a filter, drag a line crossing, I can draw the line there, and then I can join the metrics into another one, then I can calculate wait time. So anyone with a basic like onboarding can do this. You don't really need an engineer to do that. And then with some ground truth collected, you are able to just one click to run to get accuracy. Another thing we observe taking a lot of time is fine-tuning the hyperparameter. So we're also developing we call that auto-calibration agent. As long as you have the topology, you have the ground truth, it will just run, automatically give you the best topology hyperparameters. So this whole full process is automated and require very little human in the loop, so that's very scalable. All right, so this is just a whole overview of the metrics we support today, Sapphire AI. We very focus on 3 industries, the amusement park, and the retail and commercial public space. The most basic ones are throughput, ingress, egress, and for amusement park industry, we have like dispatch, we have fill rate, we have different wait times, and for retail, we also have this staff engagement, real-time occupancy, and for commercial public space, we have parking utilization, and we have this drop time and heat map visual activity for all of that. Those sound very fundamental, but those are essentially the most important metrics to drive a lot of operational optimization. And this is just a glimpse of some selected clients we're working with, and we love them, they love us, and as you can see, it's really like global and in different industries. We have amusement park, we have some retails, and we have some large property and real estate public space companies and organizations. And at the last, I want to talk a little bit stream native and the reason why we picked them. I think the first thing is resilience, especially when we do like SaaS to be business. Resilience is the non-negotiable, most important thing. Like signing SLA is like inevitable, so stream native provide a really good resilience for us. That's why we picked them at the very first place. And also, it saves us a lot of cost. We have been doing like Pulsar stream native with other solutions every quarter, and the result always the same. Stream native is being the cheapest solution for us, and also Pulsar has this register schema. It just works for ML structured output very well, and whenever we make a schema change, it's very smooth. And yeah, just a little bit more details, like we're using their tiered storage, I think roughly about 10 terabytes cluster size for 1 year. And we also have this multi-tenancy hierarchy to support different customers, and also have APIs to support the pipeline, which is very handy. And that's pretty much my presentation. Thank you.